Good morning, guys. Today, we're going to talk about solubility, precipitation reactions, and also electrolytes. This is the second of 4 Chapter 8 videos. Sorry, don't mind my dogs. They're just being a little loud playing. So, as for solubility goes, the biggest thing to remember is that likes dissolve likes. And this comes into play with polarity. Okay, so a polar solution will dissolve in a polar solution. A nonpolar will dissolve in nonpolar. If they're polar and nonpolar, they do not dissolve in each other. Okay, remember that charge distribution. Remember this is a delta, partial negative, partial positive. The negative charge will be on the most electronegative element. So what happens when salts dissolve in water? So remember, a salt is just an ionic compound. The partial negative side attracts the cation, and the partial positive side attracts the anion, and they pull it apart. So here you can see it actually dissolving. The animation is pretty cool, but it wasn't working real great this morning, so it's not in here. But what happens is, again, the oxygen in the water, which is partially negative, will come and attack the cation, which is sodium in this case, and pull it off. And then the hydrogens will attack the anions, the chloride, and pull it off. And they just keep doing that until the whole compound is dissolved. So, electrolytes, materials that do dissolve in water and conduct electricity. So they need to be ionic and soluble. Those are electrolytes. And remember, soluble means they break apart, or they're aqueous, that AQ. Materials that dissolve in water but don't conduct electricity are going to be non-electrolytes. And that's going to be molecular compounds. So those covalent molecules, or not soluble, because we have to have ions in a solution to conduct electricity. So here you can see what happens in an ionic compound that is soluble is the ions break apart. In a molecular compound like sugar, it does not break apart. It gets pulled apart from the other same sugar molecules, but it doesn't break into tiny little pieces. So there's no charges for that electricity to flow through. So electrolytes must be ionic and they have to dissolve, so they have to be soluble. There are strong and weak electrolytes, so we'll talk about that a little bit more when we get to acids and bases. But a strong electrolyte completely dissociates, which means breaks apart. A weak electrolyte only partially dissociates. So, strong ones will always have a single arrow. Weak ones will have that double arrow. Remember, molecular compounds that dissolve in water do not form ions, so they are not electrolytes. So to be a strong electrolyte, you need to be ionic, but you also need to be able to completely dissociate. So here we can see in this top image on the right, the sodium chloride completely breaks apart. Same thing with the hydrochloric acid, completely breaks apart. Down here in this bottom picture, we have a weak electrolyte, which is acetic acid. It only partially breaks. So there are what, 9? Yes, there are 9 molecules in here, and only 2 of them broke apart. But up here, when we had 4 hydrochloric acids, every single one of them broke apart. So that's the difference between a strong and a weak electrolyte. Strong ones break completely, weak ones only break partially, and normally very, very small amounts. Molecular compounds, remember, they will not break apart into ions. They stay as one piece. They do dissolve, but their whole molecule stays intact. There's no little pieces that pop off that big molecule. So this is a non-electrolyte. So here is a non-electrolyte, that's sugar. A weak electrolyte, the acetic acid. Notice this is the only piece that broke. And the strong electrolyte, all those purple and green particles are the ones that broke apart. All of them broke apart. There are no purple and greens together. So now we're specifically going to talk about how soluble ionic compounds are. This will come up again in Chem 2, but for now it's going to be pretty simple. They're either going to be soluble, which means it does dissolve, or they're going to be not soluble or insoluble, which means it does not dissolve. So in this image, you can see that this one is insoluble because there is still solid particles at the bottom of that container. So there are different levels of solubility, but again, for now we're talking about soluble or insoluble. Okay, insoluble means it's a solid. Soluble means it's aqueous. Okay, insoluble solid, soluble aqueous. And then there are different factors that allow us to predict this. If it were me, I would make sure I have this page up for the quiz or the test, even for your homework. This is just a list of solubility rules. The ones in the red box are ones I would normally want you to memorize because they appear a lot. Okay, so all alkali metals and ammoniums are soluble. All nitrates and acetates are soluble. All halogens are soluble, except when there was silver, lead, or chloride. Or sorry, silver, lead, or mercury. Okay, chloride is a halogen. Okay, so those are the ones that would make it insoluble if they were with them. These ones up here are going to be always soluble. Okay, so the exception column, if it's in the soluble section and it has an exception that it falls under, that means it's insoluble. If it's in the insoluble section but it has an exception, that means it's soluble. Okay, so you just need to know how to use this specific page. So predict whether each compound is soluble or insoluble. So chlorine is a halogen, lead makes it insoluble. Copper, well, chlorine is a halogen, but copper is not silver, lead, or mercury, so that one is soluble. All nitrates are soluble, so C is soluble. And for D, that one is insoluble, because while sulfate is normally soluble, barium is an exception. So you just have to read the chart. Okay, nickel 2 sulfide is insoluble, so I'm just going to put an I. Magnesium phosphate, insoluble. Lithium carbonate is soluble because lithium is a group 1 metal. And sodium chloride is, or sorry, not sodium, ammonium chloride is soluble. So then we have these precipitation reactions. This happens when I mix two aqueous solutions to make a solid. And then whatever's left. The solid is called a precipitate. That insoluble product is a precipitate. And this specifically is going to be a double replacement reaction, which we'll see in a minute. Some people call them double displacement. They're the same thing. Okay, so what happens is, generally, my cations are going to swap spots. Okay, so now on the other side, potassium's with nitrate and lead is with iodine. And then you have to re-look at their solubilities to see if they're solid or aqueous. If everything is aqueous, then there's no reaction. So, okay, so all aqueous. That means that no reaction occurred. It'll make more sense in the next video as to why. So, when we're predicting these precipitation reactions, we need to determine what ions of each aqueous reaction has. That way we can switch the cations. Okay, then we need to rebalance charges, and then we need to determine solubility along with balance the equation. Okay, if everything is aqueous, it's no reaction. And remember, this is super important when we're balancing. You cannot change subscripts, only coefficients. The subscripts will be moving in this type of reaction, and that's because they're ionic compounds, so we have to pay attention to their charges so they can cross and be the correct formula. But we do not change subscripts to balance. We only change coefficients. So here in this illustration, I like the particulate diagrams. They're great for y'all to see a visual. We've got potassium iodide and lead nitrate, both of which are completely soluble. Okay, so they're that strong electrolyte. When I mix them, however, lead iodide is a solid, but the potassium nitrate is still in solution, aqueous, dissolved. All right, so let's write a reaction, potassium carbonate and nickel 2 chloride. First thing we need to do, write the initial formulas. Potassium carbonate. Don't forget to leave space for a state of matter. And nickel 2 chloride, NiCl2. Again, state of matter. Okay, again, what happens is the cation switch spots. So nickel will now be with carbonate. And potassium will be with chlorine. Okay, the 2's that were from my nickel 2 and my carbonate, they canceled out because nickel and carbonate both have a plus and minus 2 charge. Potassium and chlorine both have a 1 charge. So both of those canceled as well. So now we need to do our states of matter. All group 1 metals are soluble, so that one's aqueous. Halogens are soluble unless there was silver, lead, or mercury, which nickel is not. Nickel carbonate, so that's not one of the soluble rules, so it's a solid, insoluble. This last one is soluble aqueous. Now we need a balance. In order to do that, I just need that 2 in front of KCl. All right, let's do another one. Ammonium chloride and iron 3 nitrate. So NH4Cl, Fe, NO3,3. So ammonium is now the cation. So ammonium and iron are going to switch spots, iron 3. This is going to be FeCl3 and ammonium nitrate. Okay, this is not balanced. I need a 3 here, a 3 here. All ammoniums are soluble. All nitrates are soluble. FeCl3, halogens are soluble unless there was silver, lead, and mercury. Iron is not one, so this is also soluble. And all ammoniums are soluble. So this one specifically is no reaction, and I will write RXN as an abbreviation for reaction. On Mastering Chemistry, you will have to write the word reaction out if this appears in the Chapter 8 homework. Okay, let's do another one. Sodium nitrate and lithium sulfate. So NaNO3. Li2SO4, that 2 comes from the sulfate charge. So then I have Na2SO4. LiNO3. Okay, let's balance. I need a 2 here and a 2 here. All nitrates are soluble. All group 1 metals are soluble. All group 1 metals are soluble. All nitrates are soluble. So this again is no reaction. Okay, I believe this is the last one for now. You will need to make sure you can do this because Mastering Chemistry is going to ask you to do it. There's some on the test, there's some on the, and in order to go to the next video, you need to make sure you have a good grasp of this. So I've got sodium hydroxide plus copper 2 bromide, sodium bromide, copper 2 hydroxide. Okay, all group 1 metals are aqueous. Halogens are aqueous except with silver, lead, and mercury, not copper. All group 1 metals are aqueous. Copper hydroxide is a solid. This one is currently not balanced yet, so let's go ahead and balance. I need a 2 here and a 2 here. So this one is a precipitation reaction. All right, that is it. Please let me know if you need any help with this, and If you do, you need to reach out, okay? Y'all have a great day.